Hi guys, I'm Jitender. I'm the founder of Hash Studio Technologies. As a part of this series, we are doing second webinar. First was IoT gateway. So capturing the data over Modbus and showing on the dashboard using IoT gateways. In that seminar, we presented three types of IoT gateways, and then we shown the live demo where we captured the data from energy meter multi-slave mode. One gateway was able to capture data from four energy meter, and then we shown the data on the dashboard, and we displayed the data over MQTT in JSON format. So today we are going to extend that series, and this will be the second webinar in that series, and we will be showing how to capture high-speed data and do real-time monitoring in IoT. So I have Kulbhushan, who is IoT lead at Hair Studio. He's going to demonstrate the live demo, and also he will share the technical things related to this demo.
So, hey guys, um, very warm welcome to this second webinar in the series. So, last time, as Jitender has mentioned, we did a small demo on capturing details from various energy meters, devices working on RS-232-485 and transmitting it onto network devices or connected servers and stuff. Today, what we're going to do is we are trying to capture real-time data over the edge devices or any connected devices and do analysis over it and like present that data, whatever the outcome of the data is, we're going to send that data onto a server, right? So in industrial automation, we have basically have two type of signals. One is the analog signal and the other is the digital signals. The analog signals can be your exact analog values or values from current loop sensors, from the various temperature sensors, pressure sensors, so on and so forth. When you talk about digital signals, these digital signals can be input from alarms. These can be input from various door closing sensors or magnetic sensors, read relays. So the segregation between these two is one can have any values between suppose 0 to 24 volts industry standard, and one can have only two values, that is either 0 or 24 volts. For measuring analog sensors, it has a very typical property, like some sensors have a very wide range of values they can give. So the sensitivity in that case of the device which is trying to capture the data has to be high, and it has to correspond to the exact step size of that data. Suppose current loop sensor is trying to transmit data within the values of 4 to 20 milliamps. So that means that whatever the data width it is capturing, it's converting that into a range of 4 to 20 milliamps. That means each step, like the differentiation between one data element, two data, and the other second data element would be of certain microamps. So the resolution of the measuring device has to be high enough so that it can detect that change and it can transmit that change over to the network, right? So at Hash, we have developed devices which can detect that change. We have ADCs measuring up to 12 or 14 bits of accuracy in data, and we are doing preconditioning of the data, and we are then processing that signal. So depending upon the type of input, whether it is a raw analog input or it is a current loop sense device, we are using different type of analog converters and processing systems into our systems, so we can like convert, read all those type of analog, different types of analog data into our system. Also, we are doing a lot of work into the digital reading of sensors. So we're doing a lot of work into digital reading of the sensors. So currently we have gateways that can read 5 and 10 discrete inputs, and the sampling frequency can be as low as uh, 20 ms in the case. Although we cannot process the network transmission at that speed, so we have what we can do is we can process that particular signal onto that device itself and then transmit the data out onto the servers. So there are various ways in which we can do these analysis in digital signals. But for analog signals, what we can do is we can do different type of discrete data transmission, or we can do different type of transforms over that data. If you want to suppose there is a vibration analysis that is required onto a particular use case, right? What we can do is we can perform the Fourier fast transform on that device itself, or we can alternatively transmit the data frame or the data sample at whatever desired frequency is, and that can be a maximum of uh, like for it's 14 kilohertz. So we can transmit that exact data frame at 14 kilohertz and transmit that data onto the server, or we can process that data locally. So depending upon the use case for each scenario, our devices can be uh, altered, or just the firmware part needs to be altered so that we can cater to all types of the devices, reading devices in the industry. Now, the second thing is like in terms of reading frequency, the digital signals can be read at the rate at which the data is being like the minimum rate at which the data is produced. That is the response time of the system. While in the analog systems, this rate has to be the equivalent of the Nyquist frequency. Suppose you are measuring vibrations from a device, and the natural frequency of the device falls off to be suppose 2000 hertz, 2 kilohertz, right? So in that case, if you're keeping a buffer of plus minus 20%, then somewhere around 5 kilohertz would be your exact Nyquist rate, and we can be sampling at that rate to produce the exact output of this. Why do we require that high frequency read on the analog section? Is because see, whenever you're doing a vibration analysis, you are trying to predict the anomaly in vibrations on a particular motor or a particular device. We are trying to aging analysis. You can try to do fault detection, or like issues that may arise with the bearings and stuff, or the anomaly in vibration in case of a loaded motor and stuff. So we choose the frequency of sampling and choose the frequency of the the resonant frequency of the sensor in such a way so that our application scenario is completely fulfilled, and we are capturing the exact data and investing the exact cost. Because like see, the higher the sensitivity of the uh, analog sensor, the higher would be the cost associated with it. And when you're talking about industrial use in industrial spaces, these costs may go up significantly because the component has to be temperature safe and environment safe, right? And once the data is collected and processed, what to do with this data? So what generally in the industrial scenarios, uh, some organization would require us to save the data locally inside the internet of the particular production facility, while some prefer to transmit that data away from the facility into some cloud processing centers like AWS or Google Cloud, and then process it there or store it there and do AI analysis or ML analysis on that, and then produce the output on a centralized dashboard. So our devices are capable of transmitting those data onto Wi-Fi interface or 4G Cat 4 or Cat 1 interface, and we can do transmission using your standard TCP, UDP, and MQTT protocols. So depending upon the use case and scenarios, these devices can be taken used to take data away from the collect the data from the machine and take it to the cloud or any processing end. So talking about what kind of data we are processing, we can do edge analysis on all the digital analog data. We can do frog computing, like intermediately processing one part of the data and then transmitting the difficult part of the processing onto a server, and so on and so forth. Then we can do distributed processing, like we are capturing data at one end and then transmitting the data onto the cloud in the entirety and processing onto the cloud. So this can be the, like, there can be various combinations and permutation combinations in which the devices can be used, data can be collected, sampled, processed, analyzed, and can be put to good use. Right. So in the when we are talking about high speed data processing, let me show you an example where we are doing high speed data processing, and we are taking data from a device that is rotating at some high RPM, and then we are taking that data onto a centralized dashboard out from the facility and processing it there, and then displaying it. So if you see the screen, we have a device connected to our system, and if you see
Yes, screen. Uh, your screen is visible. Just wanted to check. Allow me us 1 minute. Uh, can you, Kulbhushan, reshare your screen because it was not shared properly?
Let me share my screen. Just give me a second.
Guys, just give us 1 minute. So guys, in case you have any, meanwhile, Kulbhushan is going to share his screen. In case of any conversation or any queries till now, so we'll take a Q&A session after this demo. But since we have some time, we can do some discussions here. You can post your queries or discussion on the Q&A. We'll take it from there.
I believe my screen is visible now.
Yes, Kulbhushan, it is visible, and we can
So,
see that
yes.
some dashboard is there, some RPM and.
So you guys can see then that there is a device connected to on my table here. So this is a rotating wheel, and we are reading the RPM of it using a proximity sensor. And this is the gateway that is reading the digital values from this. So you are seeing that the motor is changing speed, and so we are seeing the relevant change on the RPM meter itself onto the board. So this is one of the examples of high-speed data processing where I am counting the pulses, and you can see we have multiple white spots onto that wheel, so that we are not just restricted to a single pulse in one rotation. We are holding on to multiple pulses in a rotation and making it in such a way, so that we are able to like reliably detect the speed. And also we are having a tick counter at that is telling us that how much count that the device has read so far. So if you can see, the value is increasing drastically while the RPM is changing constantly with the current speed of the whatever logic is written onto the motor device itself. So this is one of the example of the high-speed data being processed onto the device when it comes to RPM processing, and then all that data is being transmitted onto the cloud and being displayed onto a centralized dashboard. So this is making use of the frog processing technique, where certain parts of the processing the device is doing itself, and certain part of the processing is being done at the central server.
Okay. So Kulbhushan, it's very nice demo. Can you explain all the hardwares which is available as a part of this demo? I see that there is a one motor, then there is a driver. So can you explain one by one each component?
Yes, sure. So we have a variable motor driver here, which I'm using to control the speed of the motor through a connected controller. If I show you a shabby looking connection from this device, so we are using this breadboard mounted circuit and with ESP to control the rotational speed of the motor, and then we are using the motor driver to exactly drive the motor. And then we have a proximity switch that is connected to the digital read gateway that we have developed. And this particular gateway is doing half the processing, and the rest of the processing is being done at the server. The exact RPM calculation is being done at this device. Also, this device is just counting the ticks that is being received by this particular sensor, and then all this data is being transferred onto the cloud, being stored in a database, and then we are like showing the graph onto the screen.
Okay. So this is about hardware part, that what are the different components we have here. One is motor, then motor driver, and then ESP board which drives the motor. Then we have our gateway, so MQTT gateway, which is capturing the data from the proximity switch and sending it to the dashboard. Now, can you explain the software part in this? What are the different components of the software on the firmware side, cloud side, and on the dashboard side? Can you give more details?
Yes, absolutely. So what we are doing is the gateway that we have put here comprised of two parts. One is the modem portion of the device, which is handling the Wi-Fi or the LTE connectivity, and the other is the data processing edge of the device, taking care of the exact data processing, data capturing, analog value read, or whatever type of data you're trying to read. This gateway is also equipped with a Modbus trans receiver, single channel. So this in the entirety, this the gateway is doing multiple jobs at the time. It is at the same time it can process Modbus communication. At the same time, this device is capable of reading the text from the device. At the same time, it is processing a part of the data, and at the same time, it is preparing data for the modem to be transmitted onto the cloud. So basically, everything is a firmware code. We have two pieces of independently functioning firmware on the device. Both the devices are acting as a master for itself and the slave for the other one, so that in case of failure, either of one can determine the state of the other and can reset it or like put it into the order. Until and unless both of the devices are having some grave failure, both of the devices will take care of themselves and keep a check on the sanity of the device. So moving on from this part, uh, the cloud portion, the dashboard that I have shown you is one of our customized softwares that we offer as a service and as a platform, depending upon the usage. And this gateway can communicate over MQTT, TCP, UDP transmissions, and can handle multiple dashboards, multiple clients, multiple devices. It can even handle OTA, firmware over the air, and all kinds of updates for the devices. This is one of our developed systems that we can offer as a service as well as a platform. Then talking about the entirety of the solution, what we are doing is everything we are doing onto the device is kind of edge processing, and and the final process, the display of the data is going onto the dashboard. So
So we'll start taking Q&A. First
yes.
question is, we are taking from Vijay. What are the two devices you are talking about? I think Kulbhushan was not talking about two devices. He was talking about two modules. One is to capture the data, and second module is to send the data to the cloud.
Right.
It's not two devices, but by mistake, some word would have been used there, but it is
Actually,
two modules.
Yeah, this is a two-part gateway. One is the data capturing portion, and the other is the modem portion. So all these two portions are there inside this particular gateway. If you can see on the screen.
Okay.
Yes, if you can see on this screen. So this particular or any of these gateways, if you see this gateway is your edge processing device. So this I'm talking about that it consists of two parts. One is the data collection part and processing part, and the other is the network transmission part. Then again, a question from Venkatesh. Yeah. So brief about MQTT. So what we're doing is we are transmitting over a TLS secured MQTT server, which is basically the de facto industrial standard for transmitting data, small or large size data onto the onto the network in when you're talking about industrial automation. So we can also do certificate based MQTT. I mean, like if you want to directly transmit it onto an AWS Greengrass device, you can do that from this device itself. Other than that, you can set up your own private Mosquito server, and we can transmit data onto this.
Any other question or query? We are happy to answer and discuss. Anyone want to know technical details of device? We are happy to take it here. So Kulbhushan just wanted to know why 5 inputs are required. So can you give us a use case where, or maybe an example from the industry where we need 5 digital inputs in parallel?
So yes, I can tell you exactly. So one of our clients is into like spring manufacturing. So what we are doing is on one machine we are measuring the exact count of the number of springs that are being produced in a minute or like in the entirety. On the second input, we are taking the input from the guide wire, where the exact wire is being fed into the machine. On the third port, we are measuring the swing arms that are exactly going and forming the springs. We can detect at any point when the wire is exhausted or any of the arms are stuck. So we are using this one. Not even 5 inputs at places. We are using 7 or 8 arms, and for the entirety of the machine, we are utilizing the 10 out of 10 inputs from the particular gateway. This particular gateway is a 10 input gateway, and this one is capable of measuring 5 digital inputs at that exact time. Also, this gateway is equipped with Modbus, and so if you can, if you want to take certain data or control that particular for spring forming machine from this particular Modbus interface, you can do so. This device is functioning over MQTT, and like you can take data onto the dashboard, or you can take data onto your server, and these devices can even be directly integrated into any of the CRM services.
Right. Any other question, guys? Or anything, Kulbhushan, from your side? Otherwise, we can wind up this session. So thank you guys. Thanks for joining. I my team member will drop an email to everyone the content of this session, and we will put it on the YouTube as well. In case anyone has any query, they can drop us the email, and we will be happy to reply those queries. Thank you, guys.
Thanks, guys.
Thanks. Bye bye.